Okay, thank you. Good morning, everyone. So today we will continue our lecture. Now we move into the second part of our lecture, which now we will discuss about fluid statics or fluid in non-moving condition. So basically, the fluid is said to be static, or you can say fluid at rest, or the fluid is not moving if there is no shearing force that act on the liquid. So you can watch the video that I have uploaded in the EduNext. In the part of the when you learn about the viscosity, you will learn about what is shearing force. So basically, shearing force is force that act on the surface, or the surface of liquid. So it's not on. So basically, if you have a pipe, or this is the body of the liquid, for example, that inside the pipe. So shearing force is forces that act perpendicular to the surface of the liquid, not normal. This is the force that act normal. This is not shearing force. We call it pressure force, but this one is the shearing force. So shearing force is basically the kind of forces, one type of forces that can cause flowing fluid. So if you have no shearing force acting on the fluid, then the fluid will be in the static condition. So fluid, gas, or liquid, if they are in a static condition, it means they will be confined by a solid wall, because the nature of fluid, gas, or liquid, they will the shape will be following the shape of the container, right? So the container will be a solid wall. And for the for the static fluid, that the properties that will be really important that later we will discuss is pressure. So in static fluid, is only pressure force or pressure that that will be acting on that fluid. So pressure is acting force in terms of actually the unit is different, right? So the force that given by the fluid, which is I don't know. This is perpendicular, and what is this one? I forget the terms. If this one is perpendicular and this one is tangential, is it? Anyone know the terms in English? Kalau ini bekerjanya tegak lurus terhadap cross-sectional areanya, kalau ini bekerjanya searah dengan permukaan areanya. So that will be the difference. This one is shearing force. This one is pressure force. So on static fluid, the force that acting on the fluid is only pressure force. Is acting perpendicular to the area. Okay. So the unit of the pressure will be the unit of force divided by area. Area is the cross-sectional area. So this one is Newton, right, for the standard unit, and this one is square meters. So the unit will be Newton over square meters, or we can call it Pascal. So 1 Pascal will be equals 1 Newton per square meters. But you need to learn that the unit of pressure is not only Pascal or not only Newton over square meters, but sometimes it will also be expressed as a bar, or ATM, or kilopascal, or in other units. So you can check from this slide. Also, you can read from the textbooks how to convert pressure unit from one unit to another. Okay. The terms pressure, actually, you can express it into different kind of pressure. Some expressed as absolute pressure, some expressed as gauge pressure, and also sometimes it is expressed as vacuum pressure. So basically, the pressure that we experience in open space, or in open space, you can call it atmospheric pressure. Ya, jadi tekanan yang ada pada kondisi adalah tekanan atmosferik. So the value will be the value of atmospheric pressure is not always 1 atm. Yeah, you need to remember that the value of atmospheric pressure is not always 1 atm. Not always. 1 atm is at which point? Anyone can still remember? Muhammad Raihul?
Yes, sir.
Yeah. At which point or at which location that the atmospheric pressure will be equal to 1 atm?
Is it 4 degrees Celsius?
No, not 4 degrees. I mean, not the temperature. I mean, di tempat mana? At which location that the pressure will be equals 1 atm?
I'm sorry, sir. I think I forgot.
Okay. Anyone know the answer?
Is it at sea level, sir?
Yeah, it's in the sea level. So if your location is at the same height as the sea level, you can say that the pressure at that point is around 1 atm. If you climb to the higher places, for example, like mountains or hills, then the pressure will be higher or lower. If you go above sea level, the pressure at that location will be higher or lower?
Lower, sir.
Yeah, if the height is higher, then the pressure, the atmospheric pressure, will be lower. Vice versa, if you dive into the sea, yeah, so the baseline will be the sea level. So if you dive into the sea, the pressure will be higher. That's why if you go into diving, you need certain apparel, you need a certain clothes, you need a certain equipment in order to sustain the higher pressure. Yeah, that's one the concept that you need to remember again. Yeah, so as long as you are in the open space, the air surrounding you are in the open space, then the pressure at that point will be the atmospheric pressure. Atmospheric pressure. So anywhere, as long as it's in the open space, not a closed space, the pressure will be in atmospheric pressure. But the value is not always 1 atm. So later, if you do some, maybe in the exam or the homework, if the value of the atmospheric pressure is not known, then you can use 1 atm as the assumption. It's okay. But if it's already written, then you have to use the value. So the higher you go, then the pressure will be lower, and the lower you go, the pressure will be higher. Okay, that is the atmospheric pressure. Now we see about the absolute pressure and gauge pressure. So basically, if you can watch also in the video, basically if the pressure is only comes from the air surrounding air, I mean, so the absolute pressure will be the same as the atmospheric pressure. Yeah, so if you are in the open space, the air is under the open space, then the absolute pressure will also be the same as the atmospheric pressure. But if you the system is closed, Yeah, for example, you have air in the open, and then you have tank, tangki, bukan mesin tank ya, but a tank. Then as long as the tank is open, the container is open. Maybe the term container is better. If the container is open, what will be the pressure inside the container?
Like
if the
ATM.
container is the sea level, yes?
Is it like the 1 ATM?
Yes. So if the container is at the sea level, so this is sea level, and the container is open, so the pressure of the air inside the container is 1 atm. It's also you can also state it that the absolute pressure inside the container, inside the open container, is 1 atm. But if you later close the container and then you add some external pressure inside the container, maybe using a compressor or a blower, so the pressure inside the closed container will increase, right? It will be higher than the atmospheric pressure. Okay, you can imagine and understand, right? So if the container is already closed and then you increase the pressure inside the container, then it will be higher than 1 atm. How much depend on the supply from the compressor. Maybe 2 atm, maybe 3 atm, and so on. So the absolute pressure will be increased because it's not only from the atmospheric pressure, but you already add some external pressure from the compressor. Ya, jadi di dalamnya kalau tadinya sudah ditutup, isinya tidak hanya atmospheric pressure, tapi Anda sudah tambahkan tambahan eksternal, tekanan eksternal dari kompresor misalnya, sehingga tekanannya akan lebih tinggi. Okay. If it's open, then it comes back to atmospheric pressure. Okay, that's the absolute pressure. How about the gauge pressure? Basically, the gauge pressure is termed to measure the differences between the absolute pressure and the atmospheric pressure. Ya, jadi gauge pressure itu adalah selisih beda antara yang absolut tadi. Kalau absolut tadi kan totalnya ya antara atmospheric pressure dengan tambahan external pressure. Nah, total itu absolute pressure dikurangi tekanan atmosferik di luar ya. Yang di luar kan masih atmosferik. Outside still atmospheric pressure. So the differences between the absolute and the local atmospheric pressure will be equals to the gauge pressure. Why we call it gauge? Because it's basically the pressure that written in the pressure gauge. Pressure gauge is a device to measure the pressure inside the container. Why we call it gauge pressure? Because basically the pressure gauge will not calculate the absolute pressure inside the container, but it will directly measure the differences between inside pressure and outside pressure. Ya, jadi pressure gauge itu akan mengukur beda, langsung dia akan mengukur beda tekanan antara yang di dalam dengan yang di luar. That's why it is called gauge pressure. So for example, if the pressure inside the container is at this point, this is the absolute pressure. And the atmospheric pressure is this one. So the rest will be the gauge pressure. Okay, now we open the container. The pressure inside will come back to the atmospheric pressure. You close again the container, and then you reduce the pressure inside the container by using vacuum pump. So basically, vacuum pump, you can use it to reduce the pressure inside closed container, so it will be under the atmospheric pressure. It will be below the atmospheric pressure. Yeah, so the pressure maybe at this point reduced until this one. This one still the absolute pressure. However, now the absolute pressure is below the atmospheric pressure. Yeah, from this one until this one, now still the absolute pressure, but it will be below the atmospheric pressure. The differences between the atmospheric pressure and the current absolute pressure will be called vacuum pressure. Okay, any question until this point? So vacuum pressure, the differences between the atmospheric pressure and absolute pressure will be in minus value, because if you heard the value of vacuum pressure equals maybe 0.3 atm, so the absolute pressure will be 1 atm minus 0.3. It will be below, the absolute pressure will be below the atmospheric pressure. If you heard the gauge pressure is 0.3 atm, the absolute pressure will be 1 plus 0.3, because gauge pressure is always higher than, the gauge pressure will be higher than the atmospheric pressure. Oke ya, jadi secara ringkas, atmospheric pressure itu adalah ketika Anda berada di tempat terbuka. Gauge pressure itu selisih antara atmospheric pressure dengan absolute pressure, tapi absolute pressure-nya itu di atas atmospheric pressure. Sebaliknya, vacuum pressure itu adalah selisih antara absolute pressure dengan atmospheric pressure, tapi absolutnya itu di bawah atmospheric pressure. That's why we call it vacuum pressure. Okay, I think this one I just go through. You remember again that when you go to higher level, that the pressure is lower, and you remember again the concept of partial pressure. Yeah. So if the pressure here is actually the total pressure of the air. So if you go to the higher level, like 10 kilometers, 50 kilometers, and so on, then the total pressure of the air will be lower. If the total pressure of the air is lower, it means the partial pressure of the oxygen or partial pressure of the nitrogen will also be lower. It means the content, the mass of the oxygen is also lower. That's why if you go to higher level, like you go to for climbing the mountain or the hills, sometimes you experience a short breath because you need to inhale more oxygen, because the content of the oxygen in the air is much lower at higher level. Then in order to get the same amount of oxygen compared to the sea level, then you need to breathe more frequently. Okay, I think you can later try to do the exercise in the example. This one is just to show you that a vacuum gauge, just remember the term, right? This is vacuum gauge. So it means the gauge, the pressure gauge, but reading in vacuum. And the unit is PSI, pound per square inch. The gauge pressure are showing 5.8, but in vacuum, so the absolute should be lower than atmospheric pressure. And at that location, the atmospheric pressure is 14.5. That's why if you want to calculate the absolute pressure, which will be lower than 14.5, that's you need to understand. If sometimes you confuse whether you need to add or you need to subtract from the pressure, then the keyword will be the vacuum. Vacuum means it will be lower than the atmospheric pressure. That's why the absolute pressure will be 14.5 minus 5.8. Okay. Later, or I think you already learned about the Bernoulli equation during your TPB. Later, when we study, we discuss about the flowing fluid, we will discuss again about the Bernoulli. So basically, if head is actually not our head, bukan kepala ya. So head is termed to express energy that correlated in flowing fluid, but the unit will be in length unit or height unit. Yeah, maybe you still remember that in flowing fluid there will be like kinetic energy due to the velocity, right? And then potential energy due to the height, and then pressure energy due to the pressure. So this term of energy, we can express it as head with height unit. So we can call it kinetic head or velocity head or potential head or pressure head, or later we also have friction. But it's just for introduction. We will discuss it in detail later when we discuss flowing fluid. Okay, any question until this point? Okay, no question means hopefully you understand. Okay, now we will discuss about what we call it hydrostatic pressure. Okay, previously I have mentioned to you, right? In static fluid, the component or the properties that really matters is pressure. And for the static fluid, we call it hydrostatic pressure. It means, or it actually explains about the differences in pressure, which is occurred in static fluid, that is proportional to the height of the depth of the fluid. So it means if you have a liquid, for example, the liquid is contained in a vessel, in a container, and maybe the container is quite big and the height is quite high. So in difference of the height, there will be difference of hydrostatic pressure. Ya, jadi kalau Anda punya cairan misalnya, itu masuk ke dalam kontainer, kontainernya cukup besar, tingginya cukup tinggi gitu ya. Jadi pada ketinggian yang berbeda dari kontainer tadi, tekanan hidrostatik dari si cairan tadi itu akan berbeda-beda. Jadi tidak sama ya. So the pressure along the height of the container will be different. It will be depending on the height. So for example, you have this one. Maybe you can go to this one. We have container which is open to the air, right? With the height, for example, 100 meters, for example. At the surface of the water, the pressure will always be equal to the atmospheric pressure because the container is open. So whenever you have open container, you fill it with water, for example. So the pressure of the water at the surface will be atmospheric pressure. 1 atm if in the sea level. So if you go deeper, the pressure will be higher. And the amount of the hydrostatic pressure at certain position, for example, 8 meters from the surface, then the pressure will be the atmospheric pressure plus this one. Density times gravity times height. I think you have learned about this equation sometimes before, right? Di mana? Pernah melihat persamaan ini di kuliah apa atau di pelajaran apa dulu? Have you encountered this equation about hydrostatic pressure?
In physics, so.
In physics, okay. Okay, basically this equation just a sec. Yeah. Okay, so basically this equation, right? P below equals the atmospheric pressure plus rho times G times H comes from what we call it force balance. Force balance that we did on the static fluid. So for example, you have container in the water inside the container. So the water will be in the static condition, right? It will not flow. So you can take certain volume. We call it a control volume. Volumes mean you have length, you have width, and you have height, right? So this one you can take as the control volume, and actually this is in 3 dimensions. Okay, then you can take the notation like in x is as delta x, in y axis is delta y, and z axis is delta z. So the shape will be in the box shape. Yeah, the shape of the control volume of the water will be in the box shape. It means with the height, width, and height, with the length, width, and height is delta x, delta y, and delta z. Okay, then you can imagine that in each side of this box, there will be acting forces or pressure that acting on the each side of the box. Ya, jadi Anda punya kotak. Kotak itu sisinya kan ada 6 ya. There will be 6 sides. So in each side, there will be force that acting on the side. Ya, di 6 sisi tadi akan ada tekanan yang bekerja pada ke-6 sisi. Okay. Besides the pressure force, because you have the control volume, right? It has volume, so you have weight force as well. Weight force, which will be the direction is downward. Yeah, the weight force, the direction will always downward, but the pressure force will be different direction according to the side. Okay, then since the water in static condition, okay, since the water are in static condition, so the force act on the water will be 0. Ya, since karena si air ini ya, walaupun ini kan kontrol volume itu adalah bagian volume yang Anda ambil dari tangki tadi. Ya, karena airnya itu berada dalam keadaan diam, maka Anda bisa nyatakan bahwa sigma gayanya atau resultan gayanya sama dengan 0. The resultant, the sigma force or the force resultant comes from the pressure force, the 6 pressure force, and also the weight force. So in this control volume, in this equation, actually we only consider the sigma force in vertical direction, because in horizontal direction, in 4 sides of the box, all the pressure force are canceling each other. Ya, kalau yang di sisi-sisi horizontalnya itu gaya tekannya itu meniadakan satu sama lain. Ada 4 kan ya, yang kanan dengan yang kiri saling meniadakan, yang depan dengan yang belakang saling meniadakan. Jadi yang kita perhitungkan, so that we take account is only the vertical one, the top one and the bottom one. So there will be force at the top, there will be force at the bottom, and also there will be weight force. So this one is this one. The direction is upward. This one is this one. The direction is downward. That's why the notation, the upward force, we use positive notation. The downward one, we take minus notation, and this one is weight force. Okay, this one, I think some correction should be made with, if you pay attention. Okay, if this one is, weight force, ada yang kurang. Weight force is mass times G. Mass is density times volume times G. Volume will be delta X, delta Y, delta Z, right? So this one kurang delta Z. Okay, so later you just divide it by delta X, delta Y. So you still have delta Z here. So the differences between top part and the bottom part of the contour volume will be equals minus density times G times delta Z. Okay, which one is higher, P1 or P2? P1 is at the bottom, P2 is at the top. Mana yang lebih tinggi tekanannya? Di atas atau di bawah?
Is it P1, sir?
Yes, it's P1 is higher because it's lower than P2. Just remember again the concept, right? Okay, this is the basic concept of hydrostatic pressure. It means the pressure of the static fluid is only influenced by the position. Ya, konsep dari tekanan hidrostatik adalah tekanan dari suatu titik ya. The pressure at some points is only influenced by that point's location. If it is higher, then the pressure, the hydrostatic pressure will also higher. Okay, then we want to use that concept into this figure. Okay, you have a very large pool with uneven surface at the bottom, and then at the surface, because it's open to the air, the pressure will be atmospheric pressure. But even though the base is uneven, different shape, you have the same position, and from one position to another, it is connected to the same fluid. Yeah, there will be two requirement that the point have the same pressure as long as that 2 points will have the same depth or the same height. Ya, jadi 2 titik atau 2 posisi itu akan punya tekanan hidrostatik yang sama kalau tinggi atau kedalamannya dari suatu reference itu sama. By reference means the surface. First, it has the same height from the baseline. The second, that 2 points are connected with the same fluid. Ya, jadi selama dua titik itu tingginya atau kedalamannya sama, kemudian dari satu titik ke titik yang lain itu terhubung oleh fluida yang sama, maka tekanan hidrostatiknya sama. Ya, as long as these 2 points are in the same height or the same depth, and these 2 points are connected with the same fluid, so the hydrostatic pressure between these 2 points is the same. It means from A, B, C, D, E, F, and G, it will all have the same hydrostatic pressure. How to calculate the hydrostatic pressure at point A or B or C? Then the atmospheric pressure plus rho GH. H is the depth. However, if you see from point G to point I, the difference, the height is different. Yeah, the point G and point I are connected with the same fluid, which is water, but the depth is different. It means the hydrostatic pressure is also different. How about point H and point I? Point H and point I will have same height from the surface. Ya, kedalaman titik H dengan titik I sama dari permukaan. However, from point H to point I, it's not connected same fluid because point H are in mercury and point I is in water. So the pressure will be different, even though the height is different. Ya, jadi yang H dengan yang I tingginya sama, tapi fluidanya tidak sama. Jadi tekanan hidrostatiknya tidak sama. Sementara yang G dengan I tingginya berbeda, tapi fluidanya sama. Sehingga hidrostatiknya juga tidak sama. Okay, I hope you can understand what when I deliver the concept. So for the hydrostatic pressure, you will need to check 2 things. First is whether the height is the same. The second, whether the fluid is the same. So if the height is the same and the fluid is the same, then the hydrostatic pressure is also similar. Okay, any question? Tidak ada pertanyaan? Masih gampang ya? Okay, I'll continue. Okay, this one is the same. Okay, this is actually the application of the hydrostatic pressure, which we call it Pascal law. So if you have dongkrak itu apa bahasa Inggrisnya? Hydraulic, anyone know? The terms for dongkrak. Kalian tahu apa itu dongkrak?
Is it boost, sir?
Is it boost? I don't know. I don't think that is a boost. Later you can check but you know dongkrak, right? Something to pull up something. If you have a flat tire, then if you want to change the flat tire, then you need a tools to increase the position of the car, right? So you can take out the flat tire, then you change it to the new tire. Let's call it dongkrak. How to call it? I don't know the term in English. So, yes, sorry.
Brian typed it's a jack.
Jack, is it?
Yeah, it's called a jack.
Yeah, okay, maybe it's correct. Okay, so if for a flat tire, the jack or the dongkrak is basically just mechanical jack, right? So you increase the level of the steel part of the jack, then it can increase that position of the car. But for maybe if you go to the car wash, when you need to increase the position of the whole car, then you need higher force, right? You need because cars has certain weight force. It comes from the mass of the car and the gravity. So if you want to increase the position of the car, so you need to apply forces that can actually encounter the weight force. Upward direction. So basically, by using the hydrostatic principle and Pascal law, you can make some fluid, whether it's liquid or whether it's a gas. So you put it in some normally liquid water. So you put it in the confined place, something like this. And each of the leg, you have different area where A2 is much larger than A1. So if you apply small forces at this point, but this point have smaller area, it means you can generate pressure, right? Because pressure is force divided by area. This pressure will be delivered throughout the confined space. And Pascal law said that the pressure in confined incompressible fluid will be transmitted equally. It means at this point, at point 2, the pressure is the same as pressure at point 1. But since you have larger cross area in point 2, it means you can generate F will be equals P times A, right? So at point 2, you can create larger forces to increase, to have, in order to be able to lift the car. So this is the principle of dongkrak hydraulic. So you apply small forces at certain point with small cross area. You deliver it through the different end, which has larger area. You can generate larger force, then this force can be used to lift the car, for example. Okay. Now, I'm sorry, I haven't changed the language inside the exercise, but you can see in the figure that you have, we call it, later we will encounter this term, manometer, or we call it U-pipe, which contain 3 different of fluid, which is oil, air, and this is water. Okay, so when you feel these 3 liquid or these 3 fluid is not is immiscible. It means they do not interact with each other. They do not mix with each other. So after put it in the U pipe, the position is like this one. This is oil, air, and then the blue one is water. Okay, you can see that there will be some position or some length that possessed by the fluid. Ya, jadi masing-masing fluida ini punya ketinggian di bagian-bagian pipa U-nya. Okay, by using the principle of the hydrostatic pressure, you were asked to calculate the specific gravity of the oil. Do you still remember what will be the formula of the specific gravity? Apa itu specific gravity? Masih ingat nggak? Sudah lupa?
Sir, is it rho substance over rho reference?
Yes, actually it's the density. So if the specific gravity of oil means you divided the density of oil. If it is liquid, then the reference will be, what will be the reference? The liquid for the reference.
Water at 4 degrees.
Water. Yeah. So basically, specific density of oil is the density of the oil divided by the density of water. Then how to calculate the density of oil? yeah, you need to have the value of the density of the oil. How to calculate the density of the oil? Then you need to pay attention on the position of the fluid inside the U pipe. Okay. To refresh your understanding about the hydrostatic pressure, which position have the same pressure? Can you mention what is the requirement that the 2 points should have the same hydrostatic pressure? Ada yang masih ingat yang tadi barusan disebutkan? 2 titik itu akan punya tekanan yang sama. Kalau apa?
Is it the one in the open air, sir?
The one in the open air. It means this one, right?
And the one that's under the oil.
Which one?
It should be water and water, right, sir?
Which one? Which one? This one?
Yeah. Yes.
Okay. This position and this position will have the same hydrostatic pressure. Because if you take this one as reference, from this from this point to this point, and from this point to this point, the head is the same. And also from this point to this point is connected to water. So remember again, there should be 2 requirements. First is the head, 2 is the fluid, whether it's the same or not. Okay, and then how about this one and this one? The head from the bottom part is different, right? This one is 3 feet and this one is how much? 3 plus 1, 4 feet. And from this point to this point, it goes through oil, air, and water. Is the pressure is the same? Is the pressure at this point, it's the same?
No, sir. It's different fluid.
It's the same, sir.
Oh, I'm wrong.
Yeah, that's a bit tricky because if you consider the head and you consider the fluid, both are not the same, right? If you check from the baseline, the head is different and then the fluid also different. However, both this one are open to the open air. This one is open air. That's why the pressure at this point and the pressure at this point is the same. It will be atmospheric pressure. Okay, so you have, how about this point? At the baseline, will the pressure is the same?
Is it the same, sir?
Yes, it is the same because it's all water and the head is also the same. So you can take maybe this one as the reference or this one as the reference. And by knowing the pressure at the open air is atmospheric pressure, then you can calculate the specific gravity just by using that P at certain point will be equals P at the M plus density times gravity times height. Okay, I hope you can do it at home. Later, if you have difficulties calculating the specific gravity, then we can discuss in our next class. But I won't discuss it in detail until you get the number, but please do it by yourself. You have 2 exercises. This is actually the same, but the system a bit complex. So you have a connected tank with closed vessel, like the round spherical vessel, the closed spherical vessel, connected with the certain piping, and then it's connected to open vessel. This one filled with water, H2O means water, right? And this one filled with mercury, and this one filled with oil. Actually, it stated the Sg of the oil is around 0.8. So for this problems, this exercise, you should get the value of the Sg of the oil is around 0.8, roughly. Yeah. Okay, for this one, you can do the same. You can analyze which 2 points should have the same hydrostatic pressure by considering the head, considering the fluid. And then this is the open space. So this is also atmospheric pressure. Okay, maybe I think you do not need to consider this one. You can use gravity as 9.8, this one. And the density of water, anyone can still remember? How much is the density of the water? In SI? Berapa?
1,000 kilogram per meter cubic.
Yes, 1,000 kilogram per cubic meters. Okay, please do this exercise as well. All the information are already stated. Just be careful, the value of the density is still in Sg. So the value of the density, you need to multiply by density of water and the value of the head in millimeters. So you need to have converted into meters. Okay, any question about this exercise?
Sir, for the first exercise, do we just answer in terms of the densities because it doesn't give us the value?
Actually, later you just divide it by density of water, then you can have the value because you can cancel out the density of water.
Oh, okay.
Or if you need the value, then you can assume using the density of water is this one.
Okay, all right, sir. Okay,
any other question? Just remember again, 2 points in a static fluid will have same pressure as long as the depth or the height is the same from some reference. The reference point, you can use the top part or the bottom part. It's up to you. Yeah, as long as the depth is the same. Second is as long as the fluid is also the same between these 2 points. Okay, like for this one, right? This one and this one, because it's still water, it will be the same. However, this one and this one is not. Because this one is water, this one is oil, and it go through mercury and oil. But from this one and this one should be the same. Okay, A is in this position. Okay, I hope you can do this exercise by yourself at home so you can have more understanding about the concept. Okay, this one I think I was already explained to you. This we call it control volume. Later, when you are dealing with mass balance or energy balance, or later when you get the transport phenomena, perhaps in the lecture of transport phenomena, you dealing the control volume more frequently. Like for the mass balance, but just remember for now how to specify the control volumes. Basically, you have to make sure if you want to do the mass balance or force balance, you have to make sure that the composition inside the control volume is the same. Composition or concentration, ya. Jadi kalau untuk menentukan kontrol volume itu di mana, bentuknya bagaimana, itu Anda harus memastikan bahwa di dalam kontrol volume itu, kalau untuk neraca massa ya, atau neraca gaya, itu komposisi. Kalau neraca massa itu berarti komposisi atau konsentrasi, itu sama. So later, previously when we discussed about the tank, actually it's the easiest example because it's only water, right? So water, there is nothing inside, just water. So the composition actually remain the same along the inside the tank. Ya, kalau isinya hanya air saja, itu berarti kan komposisinya di semua bagian sama. Jadi Anda sebetulnya bisa membuat kontrol volume itu di mana-mana. Mau di tengah, mau di pinggir, mau di atas, mau di bawah, it's the same. But later, if you have reaction, maybe you have mixing, there will be some added complication. You need to know at which part of the volume that the composition is the same. As for the energy balance, then you have to make sure that the temperature inside the control volume are the same. Throughout the control volume are the same. Okay. For the fluid mechanics, the control volume is still easy. Then you can get this one. I think we already discussed previously, right? So from the force balance that we do at the hydrostatic fluid, we can get the correlation between the pressure at one point and the pressure at another point. And the correlation would be the gravity and the height between these 2 points. That's the concept of the hydrostatic pressure. And how about this one? Okay, the application of force balance once is to analyze the force that act or the force acting on the some structure. For example, this is the dam structure. Dam itu waduk ya. So the waduk, the dam contains certain amount of water. This is one part of the wall of the dam. So we have water inside the dam, and we have air outside the dam. So you can use the force balance analysis to calculate the signal force acting on this part of the dam. Okay, before we do the force analysis, let me ask you, this is water, right? Water have certain depth. Okay, is the pressure in the water is the same throughout the heat? Tekanannya sama nggak di sepanjang kedalaman air? Di kiri ada air ya. Tekanannya sama nggak di sepanjang kedalaman ini? Ini kalian pendiam sekali, tidak ada yang mau jawab.
No, sir.
No. So which one is the lowest pressure? At which point is the lowest pressure? Oops, sorry.
On the surface, sir.
At the surface. Just a minute. Okay, at the surface, the pressure is at the lowest. How much is the pressure? It will be equals to the atmospheric pressure. So the deeper you go into the water, then the pressure will be higher. So basically along the D position, D is the head of the dam wall. The left side of the dam wall will experience different pressure because of the hydrostatic pressure of water. Ya, jadi di sebelah kiri tekanan yang dialami oleh dinding sebelah kiri itu akan beda-beda tergantung kedalaman air. Yang paling atas paling kecil sebesar tekanan udara ya, atmospheric pressure. Yang paling bawah itu yang paling besar. So basically the arrow correlates with the amount of the pressure. How about the right side? The right side, it is connected to the open air. The pressure at the top part, the middle part, and the bottom part on the right side of the wall, whether the pressure is the same or different. Kalau di sebelah kanan, excuse me?
Is it the same?
Yes, why?
Because it's not affected by height. It's not a hydrostatic pressure.
Why it's not affected? Yeah, your answer is correct. You just need to elaborate further. Because it's only affected by the open air. So basically, the pressure force that acts upon the surface of the right side of the wall is caused by the open air. So the value of the pressure is constant, the same, constant throughout the height. It's all atmospheric pressure. Okay, then for the right side is easy, right? So the force balance, yeah, F total will be the force from the water, it's still in Indonesia, minus from the open air. Okay, if you have D as the height and and W as the weight, so this one is D and this one is W, what will be the total pressure experienced from the air? What will be the force experienced from the air? It will be pressure, atmospheric, times W times D, right? W times D is the area. This is the air. Okay, to calculate the force acting from right to the left side from the air is this one. Okay, how about the force from the water? How to calculate it? Because it will be different, right? The pressure throughout the head of the left side of the wall is different because of the hydrostatic pressure. Then how to calculate it? F water. Because it will be different, then you need to learn again about the calculus. Then you need to take, this is, so if you put the wall, this is the side of the wall. So this one is D, this one is W, right? This is W. You take certain height, very small height throughout this one. So you take certain height. Then you can assume that the force acting on that height, yeah, the top of this one and the top and the bottom one is the same. Because it's very, very small. Okay, the pressure is the same. And then how about the area? Area will be W times dz, or in this equation is dh. I think I can use dh. W dh. Okay, the pressure at that point will be equals the density of the water, gravity times h. H from this position. Or sorry, I think the reference will be the bottom one, so h from this one. But it's easier to calculate the h from the surface. So z equals 0 should be this one. Z equals c equal this one. Okay, so the h will be this one. plus, don't forget, atmospheric. Okay, anyone still confused to derive this P? Go. Okay, this P, the pressure at this small area. Because the area is very small, the heat difference is very small, so the pressure at the top part and the bottom part, you can assume it the same. Karena sangat-sangat tipis gitu ya. At the pressure and the pressure at that area will be the atmospheric pressure, the top, plus rho GH. H is this one. Okay, this is the pressure component. This is the area component. Then to get the F total, this is still dF, right? Because it's only force acting on that small area. So in order to get the water, total 1, so you have to integrate. P at the M plus rho GH, then multiply by this one. So that's why you have this equation. And by integration, then you can have that F total is the difference between the force by the water minus the force by the air. So you can have this one. That's one purpose of deriving the force balance. Okay, any question? Okay, this one is for the case when the wall are in rectangular shape. If you have the wall, for example, in other shape, for example, if you have triangular shape, then you need to define how to derive the correlation. Same with the before, you need to have, you need to understand how to derive the correlation to calculate the force. It means the correlation between pressure and area. Area, it means different height, right? If you have 0 and h, this one, when you go from position 8 equals 0 downward, the area of the triangle will be different, right? Yeah, it will be higher, but it will have different correlation with rectangular area. So like for this one, you can correlate the width as the function of the height like this. So you can have the area, this one. Then with the same derivation, then you can have the correlation of the force. Don't get too intimidated with the integral part and then the final equation, because you can have a different types of the case of the wall. But just remember what is the principle, how to derive the equation. It comes from this one. So you need to have to understand, you need to understand how to calculate the force coming from the water and force come from the air. Because you will have, this is only mathematics, but just get the basic concept. I think the calculation maybe is slightly advanced to you, but just try at home and then try to understand. If you still have any question, actually I put some YouTube video that explain the calculation in detail, but if you still don't understand, you can discuss with me in later meeting, later class. Okay. Okay, now we go to the buoyancy. Buoyancy is one, I think you already get the concept about buoyancy. It's really related to the Archimedes principle. So basically, buoyancy is the phenomenon that happen because when you put some solid thing inside the water. Yeah, when you put a solid inside the water, solid will have weight force, right? So some solid will have a certain mass, so it has weight force. When you put inside water, for example, the water will give reaction to the weight mass. Because the solid has density, it has mass, it has weight force, then fluid also have density. The fluid, the liquid, for example, will give certain amount of force that acting against the weight force. Yeah, so buoyancy is basically the upward force, because weight force is downward, right? So the buoyancy is upward force that exerted by the fluid that oppose the weight of the immersed object. And it is actually the application of the force balance. And you do not need to calculate the control volume and then the differences of force pressure and pressure force, but just use the concept of the buoyancy, because buoyancy is basically is pressure difference between the top and the bottom position of the object. So basically it's also a force balance. I think you still remember the buoyancy, right? So FB is the weight force. Sorry, FB is the buoyancy force. Buoyancy force is calculated by multiply the density of the fluid, the gravity, and the volume of the solid. But you need to understand, or you need to remember this one. This is buoyant. First, I will weight force. Weight force is density of the solid by gravity by volume of the solid. This is the whole volume of the solid. But the buoyancy, the notation still a bit different. This is the density of the fluid times gravity times the volume of the solid. Do you still remember? Is it the whole volume or depends?
Depends on how much is immersed.
Yes, it will be depending on how much part of the solid that immersed in the object. Ya, jadi tergantung. Kalau yang di gaya berat, volume solid itu pasti volume keseluruhan dari padatan. Tapi kalau di gaya apung, volume solidnya adalah volume solid yang terendam di cairannya atau volume solid yang dipindahkan oleh cairan. So it's not always the whole volume. Depends in how much part of the solid that immersed. If whole part is immersed, then volume solid will be the same as the whole volume. But only half, if only half part is immersed, then it's only half of the solid volume. So the net force, this is the net force, will be the weight force minus the buoyancy force. Or if you assume that the solid volume is both are the whole solid volume, then the net force will be depending on the differences of the density. If the density of the solid is much higher than the fluid density, then it will go sinking in the liquid. If much lower, then it will be floating. If the same, then it will be immersed, but in suspended in the middle of the liquid. Okay, yeah, that's the concept of buoyancy. Basically, it is derived by using the force balance. But with buoyancy, we do not need to analyze like at the top part, at the side part, at the bottom part. You just need to see when solid object is immersed, how much part of that solid immersed, ya, seberapa banyak. Volume yang terendamnya seberapa besar. Nah, volume yang terendam itu yang akan menentukan gaya apung. Okay. Some exercise you can do by yourself. It's two cases. First is the ice cube. Ice cube is water in solid form. That the density is lower. If you see the density is lower than the water is 1000, right? So some part of the solid will be in the water and some part will be in the air. So then if the density is known, then the size of the ice cube is also known, then you can try to calculate how much part of the solid that will be immersed by using the buoyancy principle. This one is also the same. You have two liquid, yeah, it's not miscible, it's not mixed with another. Then you put solid stuff, solid box inside the liquid. Then the solid box will be immersed in between the lighter liquid and the heavier liquid. Then by knowing the properties, because the solid box will have certain density, right? So you need to have V total, V solid will be V1 plus V2. And then the buoyancy will be divided into part. Buoyancy from the liquid, lighter liquid, we call it 1, right? So the weight of the box will be rho solid times gravity times Vs. Vs is this one. Buoyancy from liquid 1 will be rho liquid 1 times G times V1. Buoyancy from liquid 2 will be rho 2 times G times V2. Then by applying force balance, then you can get how much V2 as a function of V, like how much part it, whether it's 0.5% or 0.75%, etc. That's you need to calculate. Please try it also at home. Okay, any question? Ya, jadi silakan gunakan hubungan ini ya. Jadi ada gaya berat. Gaya berat itu dari si bendanya. Densitas benda dikalikan gravitasi dikalikan total volume dari si benda. Total volume ya berarti V1 tambah V2. Kalau gaya buoyancy dari liquid yang pertama, yang di atas, itu berarti densitas liquid yang pertama dikalikan gravitasi, dikalikan volume liquid yang dipindahkan benda yang di atas V1. Yang immerse di liquid 1. Sementara yang di 2 sama ya, densitas cairan yang kedua dikalikan gravitasi dikalikan V2. Nah, nanti dari 3 gaya ini silakan susun Fn-nya. Fn-nya bentuknya seperti apa? Nanti kalian bisa hitung how much volume is the volume 2 is shown in the following figure. Okay. Now we go to the last part of the discussion about the fluid static. Hopefully we can manage to finish this slide because actually some of the concept I think you already get to when you do the PPB or the high school. First, the pressure measuring device is, we call it barometer. Barometer is basically just a long tube that filled with mercury and then inversed, and then you will have the situation is like this. Yeah, the top part will be air, but in vacuum condition. So barometer is a device to calculate how much is the atmospheric pressure, the definite number of the atmospheric pressure. So by using this principle, you can have inside the tube, like at point right, yeah, at the red dot, the pressure at the red dot will be equals to atmospheric pressure. Why? Di titik merah tekanannya itu adalah tekanan atmosferik. Why?
it's the same level as the open air, sir, the left and right.
Yes, because it's the same height as this one and as this one. Because the height is the same, the fluid is also same, mercury. And one important case at this point, this one is open air. Open air means atmospheric pressure. So this one is atmospheric pressure. So if you have vacuum pressure, which is 0 at this point, then you have the height, right? Then you can calculate the atmospheric pressure at that condition. Okay, I think this one is easy. The second one, we call it manometers. Manometers is basically also a U-pipe. It measures the differential pressure, the pressure difference between 2 points. For example, like this one, you have a closed vessel containing gas at certain pressure. Then you have manometers. Gas is in the gray color, gray or purple, gray color. And then the pipe containing different fluid. For example, maybe mercury. Since this one is atmospheric, right? And this one is the gas pressure. The pressure from the gas will akan menekan, ya, gas ini akan menekan cairan merkuri di dalam manometer. It will give pressure force to the liquid inside the manometers, so the height will be different between this point and this point. We call it H. Okay, how about pressure at these 2 points? Is it the same or different? Di titik ini dan di titik ini tekanannya sama nggak?
Is it the same?
Let's say, yeah, P1 will be equals P2. Again, the height is the same. Yeah, if you calculate from this point, the height is the same, and the fluid is the same. It's mercury. And P2 will be this one, right? P atmospheric times rho GH by applying the hydrostatic concept. And actually, P1 will be representing the pressure inside the system. Okay, you get the concept of the manometers, right? So basically, it measures the pressure by calculating the pressure difference. The pressure difference is represented by the height difference. Because if you have open U-tube, U-pipe, then you fill with mercury or any liquid, the height will be the same, right? In both legs, the height will be the same because both are atmospheric. But once you connect one leg to the gas vessel, it will experience certain pressure, then the height will be different. That's the principle of the manometers. Okay, I think this one is easy to calculate P1, just summation of pressure along the height. This one is also some application for the manometers. So you have in this area, this is flowing fluid inside. So this is flow section or flow device. It means some fluid are flowing from left to right. So if you have fluid flowing from left to right, which one is higher? The pressure, P1 or P2? If the velocity is constant and the pipe is horizontal, which one is higher? The pressure at point 1 or the pressure at point 2? Please remember again your physics concept. Water or any fluid flowing from higher pressure or lower pressure? Kalau ada air mengalir, itu mengalir atau udara mengalir, Itu dari tekanan yang tinggi atau dari tekanan yang rendah dulu? Tinggi ke rendah atau rendah ke tinggi?
From high to low.
From high to low. So which one is higher? P1 or P2?
I think P1.
P1, correct. Okay, so at this pipe section, the fluid is flowing from left to right. Some fluid will flow, because it has pressure, right? Will flow to the smaller tube, and this tube is connected to the manometers, and the manometers is containing the fluid, different fluid, not water, maybe mercury. The orange one is different from water. And then it will pressure the manometers, the mercury inside the manometers, and it will be showing the heat difference. Okay, at this section, the water is flowing, but at this section, after it gives certain pressure to the mercury, and mercury shows heat difference, this section will be in static condition. You can imagine, right? Jadi yang bagian pipa yang di atas itu airnya mengalir, tapi di bagian pipa-pipa yang di bawah yang kecil, termasuk manometer, itu diam, in a static condition, showing pressure difference. So basically, the heat difference between mercury in each manometer leg, the difference is representing the pressure difference between point 1 and point 2. And by applying the hydrostatic concept, which point has the same pressure? This one, right? PA will be equals PB. Why? Because the heat is the same. You can calculate from this one, the heat is the same. And also it's same mercury. PA, you can calculate from point 1. PA will be equals P1 plus density of water, right? Because the heat difference is this one, right? From point 1. G, A plus H. Yeah, you calculate PA from point 1. How about PB? PB from point 2 is P2 plus rho 1 G A plus rho 2 G H. Yeah, from this part and from this part. PA and PB is the same. So this one and this one should have the same result. So you can calculate P1 minus P2 or delta P. And you can get delta P is basically this one. The differences between the water and manometers pressure. The differences between the water and mercury density times GH. H is the differences in mercury heat. Okay, this is the basic principle of the manometers. Later, when we discuss about Bernoulli equation or flowing fluid, we will visit again these manometers. Okay, latihannya tolong dikerjakan ya. Okay, how about but this one you can see, right? Because the mungkin yeah, this one is also okay. These manometers basically measure the pressure difference between point 1 or point 2. While this one, the manometers measure the pressure difference between the gas pressure in the vessel and atmospheric pressure. Okay. Now I want you to imagine if you have manometers filled with water, yeah, previously in the same position, right? The head position is the same. Then you connect the manometers with the vessel containing gas that have very, very high pressure. What will happen? Kalau Anda punya manometer, Anda isi air. Awalnya ketinggiannya kan sama ya. Terus Anda hubungkan dengan vessel yang isinya gas, terus tekanannya sangat-sangat tinggi. What will happen? Can you imagine what will happen? Or in this case, the pressure difference between 0.1 and 0.2 is also very, very high. What will happen?
Overflow, sir.
Overflow, yes, correct. So for this example, if you have a very high pressure of the gas, it will pressurize this one, right? So if the manometer is not long enough, so the water will be overflowing. So you need to have a very long leg of manometers. In this case of this one, it will also cause the overflow. So the mercury will be flowing out to the pipe. We do not want it to be happen, right? So for this case, normally we use very high density of manometer fluid. Because very high density, then for very high pressure difference, you will have less heat difference. Ya, jadi biasa kalau manometer cairannya itu bukan air, karena kalau cairannya air begitu nanti dipakai ngukur gas yang tekanannya tinggi, dia muncrat. Kecuali manometernya kakinya sangat-sangat panjang, gitu ya. That's why for manometers we use mercury. Mercury will have. Do you remember? Is the specific of the mercury compared to water? How much times higher? Berapa kali lebih banyak? Ada yang ingat? SG of mercury. I think we have in the previous slide. This one. Oh, sorry. Yeah, this one. Mercury is 13.6, higher than water. So if you have higher density of liquid, this one, for the same pressure difference, you will have lower heat difference, right? So by using mercury, the overflow case can be prevented. However, in real condition, using mercury is quite dangerous, right? So for measuring a system that containing very high pressure, normally we are not using manometers. We can use what we call Bourdon tube. Have you seen this kind of device before? Maybe at home? Ada yang pernah lihat gauge seperti ini?
On the like a tire pump, sir.
In the tire pumps or at home, you have a gas stove, right?
Oh yeah.
If you have gas stove, normally before the gas comes from the cylinder, before go into the stove, you have regulator, right? And regulators is also attached with this kind of gauge. So basically, this we call it a Bourdon tube. So Bourdon tube correlate pressure with if you have pressure inside the cylinder, for example, cylinder is this one, right? And then it has pressure. Then the pressure will goes to the tube, and then it will expand the plate. So this one, the Bourdon tube will be expanding, and the expanding tube will pull, or yeah, it will pull the mechanism, so it will correlate it with the needle that's showing the value of the pressure. Yeah, it's still pressure gauge. It's still pressure gauge. It means it's calculating the difference between the pressure inside the cylinder and the pressure from the atmospheric tube. But the system is more complex. It consists of several stuff, right? Like the tube itself and the connection and the needles and then some mechanical mechanism, right? Ya, jadi ada gigi-giginya gitu ya. Nah, it will create some movement when experience certain pressure by comparing with the atmospheric pressure. Okay, another types to measure very high pressure is normally like people from mechanical engineering. They're using what we call dead weight tester. So you have like a piston inside, and then in the chamber you have oil, yeah, because oil will sustain some pressure, and then you also have standard weight, and then you have reference. This chamber is connected. This okay, you have a certain weight put in the piston, so it will give some pressure to the oil, and then you have reference pressure port, and then the one that you want to check the pressure is from this part. So by comparing the weight and the reference pressure, then you can have the value of the pressure experienced by the dead weight tester. So it can measure extremely high pressure, up to 10,000 PSI. Like for some application requires high pressure, then you need to check how much is the pressure coming from that device, then you can use this one. Okay, any question? Okay, if you don't have any question, I think this is the last part of the fluid static. The concept is simple, and you just need to refresh the concept, the hydrostatic, the buoyancy, the force balance. We have discussed it in today's class. Then please do the exercise. And later, I think Pak Haryo will give some homework to do. He will prepare some homework in order to you to more familiarize yourself with the concept in some application of fluid static. Okay, is there any question? Okay, if you do not have any more question, that I think this would be all for today. Thank you very much for your attention, and we will meet again next week. Thank you and good morning.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.